we are moving to the next presentation in this day, and that is the topic of keyword extraction. And this topic will be presented by Senja Pollak and Ivar Krustok, who is coming from Ekspress Media from Estonia. So Senja and Ivar, the floor is yours.
Thank you very much, Marco. Yes, so as introduced, so you have heard me before. Ivar is from Ekspress Media, and he will say a few words about him. And the topic, it's about article tagging. So with keywords, so which is very important for linking the articles later, for organizing the archives. I believe every media house has some sort of keyword tagging behind or would like to have one. So Ivar, please go ahead.
So as mentioned, I'm Ivar Krustok. I run the IT department in Ekspress Media. Here I'm representing our editorial team. So currently we have the issue that we have around 300 publishers, people who write articles. They might be editors, they might be guest editors. They're people who provide us with content every day. We get around 300 to 400 articles each day. So if you take one person, they write about 10 articles every day, and every article always has to have a keyword attached. Keywords help us combine these articles. They help people find them on Google. So that means we're trying to keep the keywords as neat as possible, but we're still trying to give the editor some choice, so they wouldn't add just one keyword, but rather had a more variety. Because of this, we now have more than 66,000 different keywords. Most of them were already deleted before this EMBEDDIA project, but still our system is full of keywords that are not widely used. There might be only one attached. So we have a huge issue where we would like to have our editors be provided with keywords, but try to also limit what they can choose, and rather than just having a hard limit, provide them with valuable keywords that they can choose.
So I will present two different methods for two different use cases. So keyword tagging, in general way, you have, as Ivar said, so you have an article, and then you would like to recognize, for instance, which keywords in the article are the ones that are the most important, that represent the meaning of the article the best, and that would be the most useful to, let's say, link the articles to other articles. If you have an existing collection of labeled articles, then you use supervised approach. So if you are, let's say, a media house and you have been already using keywords that you assign to your articles, but you would like to make this process more automatic. In that case, supervised approaches are good. So it means that you have available training data and you would like to learn from previous examples that your journalists or editors assign the keywords. You would like to train a system that would now do it automatically. The positive part is that such systems are adaptable. So it means that they would adapt to specific way you are using the tagging for. You can imagine that sports articles have different keywords. They might be short articles, and then you have very long articles which would have totally different type of keywords. Not only in media houses, but we might have scientific articles that again have different keywords. And different media houses, they would have different policies. Some of them would like 2 to 3 keywords, and the others would like to have 20 keywords per article. So in supervised approaches, the system would learn how to mimic your process and then propose the keywords in a similar way. And the positive part is also that these systems provide quite high results. So next slide, please. So we have developed a TNT Kit system. So it's called transformer-based neural tagger for keyword identification. So it's a neural approach, and it's a sequence labeling approach. Basically, if you have a text, here in this case, you have one sentence. It has been another record year for renewable energy despite the COVID-19 pandemic. You would like to you transform the text to numerical form, and you would like to get the output, like if zeros are non-keywords and 1 are keywords, you would like to identify which sequences of words are keywords. In this case, renewable energy and COVID-19. And if you have such systems, then you can have as output at the end, like keywords that are proposed to the editors. One of the advantages of our system is that we need only a small data set with keywords. So for instance, that you are not doing any keyword tagging right now, but you have your news archives. And if you're prepared to label, let's say, only 200 articles with keywords, our system will already produce very good results with the style adapted to your way of tagging. So we have evaluated this in scientific settings. We showed that we achieve state-of-the-art performance, and especially we are strong in settings where there are small amounts of available data. But we have also pre-trained the models and made them available. So as for English, Estonian, Croatian, Slovenian, Latvian, we have the pre-trained models, meaning that they can be directly integrated in the system. It will in that case not mimic your style, but the style of the data that was used as input, but they are working and proposing keywords, and you can test them. But there is also the code. So if you want to train it on your system, you can do it in a few days' time, I believe. Next slide, please. But in some cases, we don't have any labeled articles. So we might have a setting where we just want to select keywords. Maybe there are languages that for which we don't have any keyword data sets. We can use cross-lingual transfer there, but in some settings you don't have any examples. You just want to quickly integrate a system that will select keywords without any training and work off the shelf for any language. So these are unsupervised approaches. So they're ready to use. The results are lower. They're not adaptable to specific style, but they are ready to use, and they can be used across many languages. So we developed a system called Raccoon. It uses technology. First, it presents text as graphs, then it ranks the words, and it uses some node aggregation techniques. But basically, it's a ranking system of words in a text and of multi-word expressions. And this works for any language, and it's very fast. So this can be directly integrated, and it is an interesting tool for many, many languages. I must point out that when I say for any language, yesterday I just received a mail from a person from BBC who was playing with it, and they say, yeah, but for Chinese it didn't work that well. And in fact, we had quite a Europocentric view, because we split the words by space, and that was not the case there. So for any language for the moment, it works well for the languages where a space is a separator between words, but in future we will try to tackle it also for other languages. And as said, this is a very fast solution without any need of GPUs and so on. Next slide, please. So in terms of availability and access points, so all the code is available, making that you can train the supervised system for your own data sets. You can check how exactly the unsupervised system works if you feel like you can even adapt it, but everything is transparent how things are trained. Then you have the Dockers available. So you can use the pre-trained models as well as the unsupervised system directly. So it can be directly integrated in any working environment. But then we have also the demos, and Ivar, he will show a few examples. So you can try it out yourself.
Please let me know if you can hear the audio, or will I have to talk over it?
Yeah, you have to talk.
It's quiet.
It is quiet, or
yeah, but
no audio.
no audio. Okay. Okay, then I will just talk over it. 1 second. I'm going to turn my voice over. Okay, so this is an article that we have published in our site, and we're taking all of the text from this article. So we already know about this article. This is one of the articles that was in our tag set, and we're choosing two different tools. So one is the TNT Kit that was mentioned before, and the other is the Raccoon. So the TNT one is already trained on Estonian language, so that means currently we see from our test that it's also providing us specifically better results. The Raccoon is also providing us with keywords and without any training of our data sets. So in a moment you can see different keywords extracted by either the TNT or Raccoon. So one is a bit wider, but again, because in the end, our tools will be given to the editorial staff. So that means they can choose exactly what keywords they would like to add to this article. And next, we're going to take one article from CNN. This is an English language article, just to compare how it works from an article that the platform has not been trained on. And we're going to choose the Raccoon one, and we're going to choose the TNT Kit that is in English. So we should get the results any second now. Here we can see again the Raccoon one provides us with more keywords. For this article, the TNT Kit one didn't provide us with that many keywords because I took a small slice of the text from there, but still it provided us with keywords. We can also try the named entity extraction. So here it tries to understand exactly what type of named entities are inside the article. So might it be a person, might it be some governmental institution, something local, they are colored differently. So again, from our side, we can use this data in order to have better value keywords inside the article. Going back to the slides. So why we find this useful and why we're already starting to integrate this is because we find that it saves time for the editorial staff. So this means immediately after they write their article, they will get a good selection of keywords that they can add to their article rather than going over the text for themselves and trying to figure out what keywords are important. They're already given a set of keywords. From our side, it's also really easy to use because it will be integrated to the correct platform. So our own CMS, they don't have to go to the EMBEDDIA toolset, but because you can just take the code from GitLab and implement it on our side. And again, so this means the integration is super easy. That means from our side, the development time to add this into our platform compared to building something of our own is just a massive time and cost savings from our side. And that is all from our side.
Yeah, so
thank you.
So, yeah, so just to summarize, so here we have seen how it's the integration plans for Ekspress Meedia. We made also some specific adaptations. So we were asked that, for instance, for TNT Kit, which returns only a small number of keywords because it's trained on the number of keywords that were provided in the dataset. And in the final dataset, there were usually 4 keywords, but Ivar suggested that we would always have 10 keywords because the people would like to choose from a larger list. So what we did later is that then we complemented these results with the text, with the keywords selected from their existing text set, because they said they would like to prioritize those texts. And so it's just to show that we can make specific adaptation then for real industry needs. So we have like quite general tools, and then for each specific setting, there can be additional hacks based on the needs.